Hello, happy Wednesday. This might be my last YouTube video of the school year. I might have one next week, but I'm not quite sure. We're finishing up algebra this year with rational expressions, and today we're going to be working on polynomial long division. If you see me looking over here, it's because I have my other device set up so I could look at problems because I forgot my book. So polynomial long division. You have to remember how to do long division with just numbers. So just kind of as a quick reminder, let's just say, I had, I don't know, 32 into let's say I'm doing this. 4,798 divided by 32. Or you could say 32 into 4,798. And just as a reminder, you're asking, can 32 go into 4? No. Can 32 go into 47? Yes. How many times? 1. Then you multiply across. You get 32. And right here, what do you do right there? Because that is going to be a big reminder for today, because I'm going to ask that a lot today. You subtract. So then you subtract this down, you get 5, 1. And then, as a reminder, you bring down this 9. So 32 into 159, I don't know. It's not going to be 5, because 5 times 3 is 15. So let's go 4. And so multiply across. So 4 times 2 is 8. 4 times 3 is 12. Subtract. And it might seem silly. Oh, that almost went in 5 times. I was only 1 away from getting it to go one more time. Dang it. Anyways, and I know this might seem a little ridiculous I'm doing this, but these are the steps you need to know for polynomial long division. So at the end here, you're going to bring down this 8. So now 32 into 318. I'm going to go 9. It's not going to be 10, because that would have been 320. I'm so close. I'm so close. 8, carry the 1, 27, 28. And then you got to subtract down, go over here and borrow. 2, 3. Okay, now this part. When you guys were learning how to do long division, you learned remainders in a couple different ways. You could have gone 30 over 32. You could have just done with an R30. There's a couple different things you could have done. You could have made a decimal and a 0, brought that down, and continued dividing. So that way your answer would be in decimal form. But for today, what I need you to do for your remainders is to put your remainder over your divisor. And then, of course, that would be simplified down at least by, 2, 5, 6. Yeah, at least by 2. So you'd get 15 over 16. 15 sixteenths. So your answer would be 149 and 15 sixteenths. This remainder thing, we got to remember that. So it's the remainder over the divisor. So now that you've had a quick review on how to do long division, now we're going to do this with polynomials. And I keep telling my girls that rational expressions is fractions on steroids, which is, that's kind of what it is. And so for this first example, we're going to start out by dividing trinomial by a monomial, to kind of get your brain, I should say, going on long dividing with something that's not just a constant. So here we go. So we have divide the quantity 3x squared plus x minus 6. We're going to divide that by 3x. Okay, now this one, I'm going to do this a little bit differently, because what this problem is gearing you up to is gearing you up for the fact that you've got to divide each term is being divided by 3x, because it's the whole quantity. So that tells you each term has to be divided by 3x. So this is what it looks like. So we go 3x squared divided by 3x. So it's almost kind of like you're going to do 3 little mini problems. Then you have x divided by 3x. And you have negative 6 divided by 3x. This is a positive. And then you look to simplify each little division problem. So 3x squared divided by 3x. So 3 goes into 3 one time. And if you have 2x up top and 1 on the bottom, that means you have 1 left over that's on top. So the first term is x. Go ahead and simplify this. So remember, this is a 1x divided by 3x. The same thing you have on top is x. So x goes into x one time. And so what you're left with is plus 1/3. This is where this 1 is going to come in handy. So in class, I've been, when we've been simplifying, when we multiplied and divided, I'd be like, remember what you're saying, x plus 6 goes into x plus 6 one time. So we're going to start to see these ones that we need to use today. And the last term, negative 6 over 3x. So 3 goes into both of those. 3 goes into 3 once down here and 2 up here. And you can't do anything more because there's no x in the numerator. So you have minus 2 over x. It's a little funky looking, but that's your answer. So you took each term in your trinomial and divided it by 3x. So it became 3 little mini problems. This is going to help us for the long division, which is coming up right now. Here we go. Example 2. Divide. And this is your long division. I gotta admit, I kind of miss doing my YouTube videos. Even though I don't have the girls talking back with me, I miss doing them because I know lately I've had a bunch of, not a bunch, but I've had former students say, Miss Parks, I still follow you and I watch your videos. I'm like, oh, you miss me. So I really miss doing this. So here we go. Divide m squared plus 4m plus 3, and you're going to divide that by the quantity m plus 1. Okay, let's set it up. So we're taking this and we're dividing it by this guy. M plus 1 is your divisor. So m plus 1 is outside the house. And then m squared plus 4m plus 3 is inside the house. We got to remember our long division steps. Okay? But when you do polynomial long division, what you're actually looking to divide is just the first term in your binomial. So you're not going to look at this plus 1. And you're going to divide it kind of like you did here. You're going to go, can 32 go into 4? No. And technically I should have put a 0 up there. But then 32 went into 47. So that's where I'm starting. Here, I'm only going to divide m into this over here. So can m go into m squared? Yes. And it goes in m times. And what did we do over here? We multiplied across. We then took 1 multiplied by 32. We multiplied over here. So m plus m is m squared. M plus 1 is plus m. And what do you do out here? Subtract. Okay. M squared minus m squared is nothing. If you don't get the first term to cancel, you might have divided incorrectly up top. Right there. So that's a little hint you want to look for. These guys should be the same term. And so now we go 4m minus m. I cross off the ones that cancel, just to kind of help me keep it clear on what I'm doing and what I don't need anymore. So 4m minus m, you can't go 4m plus m. No. Because remember, you're subtracting each term. So 4m minus m is 3m. And what did we do over here? You brought down the 9. So now you're going to bring down this 3. That guy goes down. And now, you're asking, we're not going to look at this plus 1. We're going to cover that up. So can m go into 3m times? And if you don't like that, think about what up here times m gets me 3m, if you like that way better. And that's going to be a plus 3. And Some teachers are super picky about where you line these up. I just put it up top. Technically, this M's supposed to be over here, but that's one of the things I choose not to be picky about. So here we go. We're going to multiply this across. So 3 times M is 3M. 3 times a positive 1 is positive 3. What do we do out here? Don't forget that part. We subtract. 3M take away 3M. So if you have 3 monkeys and 3 monkeys run away, you don't have anything anymore. 3 minus 3 is 0. And since there's no remainder, you're finished. So now you got to figure out what the answer is. Well, just like up here, your answer is up top. So your answer to this problem is actually M plus 3. And yes, my kids, I call that a cookie. If you want to put that in parentheses, you can. The cool way you could check these when you have no remainder, take M plus 3 and multiply by M plus 1. If you get that, you divided correctly. So the product of 1 and 3 is 3. The sum of 1 and 3 is 4. And we did it. All right. I'm going to get going on a problem that now has, what's the next one? It's going to have remainder. All right. So example 3. I brought my rags back to work, and so now I just have paper towels, and it's kind of thrashing my board. Oh well. So example 3 is still going to be divide. And we have something squirrely here. I need to erase that so you guys can see that. Okay, here we go. Divide 2 minus 7y plus y squared divided by y minus 3. That should look really funny to you. Remember in polynomials, you always want this guy. Highest term over here, lowest term over here. That, as a reminder, is your standard form of a polynomial. So let's put this in order. So we have y squared minus 7y plus 2. Cross that off. That's much better. My brain can handle that a little bit better. We're going to take that and still divide it by y minus 3. Okay. So this is being divided by y minus 3. So y minus 3 is your divisor. So that goes outside the little division house. We have y squared minus 7y plus 2 inside the house. I don't know when I started calling it a house, but it was probably like 15 years ago, something like that. I don't know. Cover this minus 3 up because we are not worrying about that. We are just figuring out how many times y can go into y squared. The only time you use the other part of your binomial is when you multiply across, because it's the distributive property. Here we go. So y squared divided by y. Also, you can think about what up here times y gets me y squared, and that's y. Multiply across, multiply y times y, which is y squared, and here is where this other part of your other term, in your binomial comes in. Y times a negative 3, which is a minus 3y. What do we do out here? Subtract. Y squared minus y squared, nothing. So remember, if your first term doesn't cancel out, if they don't cancel out every time you divide, then you did something wrong. You didn't do this part right here. Here we go. Negative 7y minus negative 3. So negative 7 minus a negative 3. Don't forget to always subtract something. You can't just work down. You can't just work down because remember, you're subtracting a whole quantity. So really, you could if you wanted to. I've never done this just because it gets messy. But remember, this is like distributing a negative 1. Same thing. So negative 7 minus a negative 3. So that becomes a negative 7 plus 3, which is a negative 4y. What did we do over here? We brought down the 9. So we're going to bring down this plus 2. And now, cover up this negative 3. Negative 4 divided by y is up here. The other way you could say that, what times y is negative 4y? And that's negative 4. Multiply negative 4 across, so negative 4 times y is negative 4y. Negative 4 times negative 3 is a positive 12. What do we do out here? Subtract. So negative 4 minus a negative 4. Negative 4 minus a negative 4. Which is negative 4 plus 4. Nothing. 2 minus 12. Negative 10. Can you add a decimal? Have you seen decimals in polynomials? No, so no decimal and a 0. For remainder, since this is your remainder, we're going to put that up here. So it becomes remainder of negative 10 over your divisor, which is y minus 3. And we're going to rewrite that answer so it looks a little bit prettier. So your actual answer to the problem, remember, it's always on top of your division house. It's y minus 4 with a remainder of negative 10 over y minus 3. I make this really obvious that that's a remainder. I put a big O space in between. You might see this negative sign out here. You might see it like that. But just remember this whole fraction right here is negative. I just put it with the numerator. So you would say this, like say this is problem 3. Problem 3, y minus 4 with the remainder of negative 10 over y minus 3. So the only difference between example 3 and example 2 is the fact that we had a remainder. That's all. What do you guys think of this so far? And I know you can't answer me, but hopefully you answer it at home. Do you guys like this? Is it weird? Like, is your brain still going, oh, what do I do next? Dang it. That's why I have this guy. Just to kind of remind you on what we did. It's also just a good reminder of long division anyway. I'm sure you guys thought you were done with long division a long time ago. But you're not. And in Algebra 2, they're going to teach you something called synthetic division, which I really like it. I think it's fun. It's like upside down stuff. It's really cool. I got to teach that a couple years back when I taught at the high school for a little bit. It's fun. I think synthetic division it's actually fun. I almost said funner, but that's not a real word. It should be a real word. I'm just going to say it anyway. It's funner than this one. And it seems faster. You don't have to do the, oh, what am I doing again? Do I have to bring this down? What am I multiplying again? There's none of that. So, synthetic division, coming your way, kids. Algebra 2. Like, that's in the beginning of Algebra 2, so that's good. You don't have to wait a whole year. Okay, that was a little trip down memory lane there. Here we go. Divide 3q squared minus 8 divided by q minus 2. So what makes this problem different than the last 3? Has to do something with that one. Quadratic constant. We are missing our linear term. So what happens on example 4, this is like a missing term problem. Missing term. And earlier in the year, when you had missing terms when you added or subtracted, I said you could either leave it blank or you could fill it in with a 0 and whatever the term might have been. So, 0x to the third or whatever kind of a thing. With this, I want you to fill in the 0. I need you guys to use it with the 0 and then, whatever term it is. Okay? So whenever you don't, let's say this was like 3q to the 4th minus 8, then you'd have to fill it in with a 0q to the 3rd, a 0q to the 2nd, and a 0q. So you got to fill in your missing terms with as many as you need, as long as you can see each one of those the powers decreasing. So keep that in mind. I remember one year I had an advanced algebra class, honors algebra, and I gave an extra credit problem where it was, I want to say it was a sixth power and a constant. That was a whole lot of zeros to fill in. But it's the same process. You just fill in your terms and you keep doing this for a really long time. Okay, here we go. So q minus 2 is on the outside of the division house. I'm drawing a blank on what it's technically called right now. So 3q squared, we're going to fill it in with our linear term, plus 0q minus 8. And you do this the same way you did the other bunch of problems. So you're going to cover up this minus 2. How many times can q go into 3q squared? Another way I could say that. What up here times q gets me 3q squared, which is 3q. Let's multiply across. Let's see if I did this right. 3q times q is 3q squared. I did. So if you just accidentally put 3, when you multiply across, you'd only get 3q down here, which 3q is less power than 3q squared. So that's a good way to check to see if you actually did your division correctly up here. And then 3q times a negative 2, which is a negative 6q. What do we do out here? Subtract. 3q squared, take away 3q squared. Nothing. And I like to cross those out when I'm doing polynomials. Just so I know it's like, okay, I don't have to pay attention to this. I don't have to look at this anymore. I really need to get my hair cut. And now 0q minus a negative 6q. Remember to always come out here to subtract it. Because if you did 0 minus 6q, that's negative 6q, which is a whole lot different than positive 6q. So you've got to make sure you always here subtract here, here subtract here, here subtract here, here subtract. Just keep doing it over and over. And then bring this guy down, just like we did in here. Bring down your minus 8. And now back up here, remember it's q into 6q. Or what times q gets me 6q, which is a positive 6. And multiply across, so 6 times q is 6q. 6 times negative 2, which is a negative 12. What do we do out here? Subtract. 6q minus 6q is no q's. Negative 8 minus a negative 12. Negative 8 minus a negative 12 becomes a negative 8 plus 12, which is a 4. What is that 4 known as? Hopefully you guys answered me as your remainder. So we're going to put this guy up here. And what do we put it over again? Our divisor, which is this guy, q minus 2. So if you need to go back here, remainder over your divisor right here. And then we had to simplify that one. Okay. I know it gets kind of messy up here. I always like to rewrite it. So my answer is 3q plus 6 with a remainder of 4 over q minus 2. When you check these answers with remainders, you can't really. Just so you know. If you have a remainder of 0, super easy to check. I mean, there is a way to check this, but I am not going to go into it. It's pretty lengthy. Okay. Well, since this video is already like 25 minutes, I don't know if I should do extra problems. I'm thinking no. I'm thinking if you want more problems, you guys will contact me, I'm thinking. So I'm going to cut it here. polynomial long division. It's just like long division, but now you have letters and powers. So just think back, what am I doing now? Oh yeah, okay, multiply, cross, subtract, subtract, subtract. Don't forget to subtract down. Okay. Everyone have an excellent day. Be excellent to each other, as Bill and Ted would say. Oh my God, that's a poem. But most importantly, be kind. Have a great day. We'll see ya.